2 billion people will be able to watch an asteroid the size of a skyscraper slide past Earth closer than many satellites. It's scheduled to happen in April 2029. Now, an asteroid of this size comes this close to our planet just once in 7,500 years, and it has to do with a strange interstellar visitor called 3I Atlas that recently shook scientific certainty. Here's how. The Atlas Survey System, a nickname for Asteroid Terrestrial Impact Last Alert System, that's a mouthful, well, it scans the sky every night looking for objects that might threaten Earth. When it first flagged 3I Atlas in 2025, it appeared as a faint smudge in telescope data, the kind of thing astronomers almost ignore because the sky is full of harmless junk. Then, scientists calculated its speed and direction and realized something was off. It wasn't bound to the sun like most comets and asteroids. Space objects usually follow clean curves dictated by gravity and sunlight. Sunlight heats a comet, ice turns to gas escapes – hey, I know all about that – and that tiny push slightly alters its path, like a slow leak nudging a balloon. 3I Atlas didn't just nudge, it lurched. It accelerated in ways that didn't line up neatly with heating models. It was moving too fast, on a path that screamed interstellar origin, which means it came from another star system entirely. It shifted direction slightly but persistently. That kind of motion means our models weren't telling the full story. Researchers figured out the object's structure must be unusual, like a fragile pile of rubble venting gas from unexpected pockets. It was also possible that its surface chemistry reacted differently to sunlight than anything we've seen before. And maybe it meant that tiny forces scientists usually ignored actually matter more than they thought. NASA and the ESA both emphasized that this thing, I'll just call it 3I, wasn't an extraterrestrial spacecraft, unlike what the internet crowd supposed. It sent no signals, there was no propulsion or artificial materials involved, just ice and dust. Nobody feared 3I would hit Earth, that part was clear, but they worried they wouldn't be able to predict its behavior. Space safety depends on knowing where things will be tomorrow, next year, and decades from now. 3I showed that even small bodies can act like trick coins instead of clean equations. And this knowledge is important to predict the behavior of our today's featured thingamabob, the asteroid Apophis. It got its nickname after the Egyptian deity of chaos, which is a bit worrying already. This bad boy will pass less than 20,000 miles away from Earth. Sounds like it's no biggie, but that is closer to our planet than the satellites that handle weather forecasting and global communications. Around 2 billion people living all over Africa and in Western Europe will be able to see it with their unaided eyes. Earth's gravity at that distance won't just wave hello, it will grab Apophis hard enough to potentially change its spin, crack its surface, or shift its internal structure. Scientists call these tidal forces. Think of it like squeezing a stress ball. You don't break it, but you don't leave it unchanged either. Now, before scientists studied 3I Atlas in detail, Apophis felt manageable, and its orbit looked pretty stable. Its flyby was supposed to be a controlled event. But when they learned more about 3I Atlas, scientists started framing 2029 differently, not as danger, but as a stress test. If Earth's gravity nudges Apophis even slightly, models need to capture that in real time. That's why the European and Japanese space agencies developed the Ramses mission. It's a spacecraft packed with instruments and a Swiss-built high-resolution camera that will observe Apophis up close during the encounter. They want to see ruptures forming, dust shifting, spin rates changing. It's basically the asteroid equivalent of a human heart monitor. Now, the good news is that Apophis won't hit Earth in 2029, and scientists say that clearly. But safety depends on predictability, and predictability took a hit when 3I Atlas misbehaved. So the scientists are now watching Apophis closely to test their assumptions in the safest way possible, with a known object, a known time, and every telescope pointed straight at it. Of course, they didn't take their eyes off 3I Atlas either. One of NASA's newest spacecraft, Europa Clipper, is cruising toward Jupiter right now, with a long trip ahead of it. On the way, scientists realized they had a perfect chance to point their instruments at this interstellar comet. From about 102 million miles away, Europa Clipper turned its camera and watched 3I Atlas drift by. What it captured isn't something your eyes could ever see. The image came from an ultraviolet instrument designed to study Jupiter's icy moons, not comets, and it observed 3I Atlas for 7 straight hours. Ultraviolet light reveals gases and elements that stay completely invisible in normal photos. It's a way for scientists to see the comet's chemistry in action, instead of just its shape. That glowing cloud around the comet, called the coma, tells us what's escaping from the ice as sunlight hits it. By studying how those gases spread and move, scientists can learn what 3I Atlas is made of and how active it really is. Now, so far, scientists have had a chance to find some pretty unusual things about its chemistry. Radio telescopes in the Atacama Desert locked onto the comet and picked up clear signals from methanol and hydrogen cyanide. These two molecules that sound boring and somewhat deadly until you realize they sit right at the entrance ramp to life chemistry. These weren't tiny traces either. 3I Atlas pumped out methanol at levels that jumped sharply as it approached the sun. They spiked right where water ice starts to vaporize. Compared to most comets humans have ever measured, this thing came loaded. Its methanol to hydrogen cyanide ratio landed among the most enriched values ever seen. This doesn't mean that 3I Atlas carries life, or bacteria, or anything even remotely alive. But these molecules matter because chemistry doesn't jump straight from rock to organism. Life, at least the kind we understand, builds itself step by step. Hydrogen cyanide plays a key role in forming amino acids, the Lego bricks of proteins. Methanol acts like a chemical multi-tool that helps assemble more complex molecules, like sugars and the precursors to DNA and RNA. On 3I Atlas, methanol made up about 8% of its vapor, and that's roughly 4 times what we usually see in solar system comets. Another cool part is where these ingredients for life came from. 3I Atlas formed around another star inside another planetary system, under conditions we can only guess at. And yet, it shows up carrying the same basic toolkit that life on Earth relies on. That lines up with an old idea scientists have kicked around for decades. Comets and asteroids might act like delivery trucks, scattering water and organic molecules across young planets. Earth may not have invented its chemistry from scratch. It may have inherited it. Now, before 3I Atlas, we had only confirmed 2 interstellar visitors, Oumuamua in 2017 and 2I Borisov in 2019. Oumuamua freaked everyone out because it didn't look like a normal comet at all. It had no obvious tail, showed weird acceleration, and was of a cigar-like shape. So the internet went wild with crazy extraterrestrial theories. Borisov felt like a relief by comparison. It behaved exactly how a comet should, growing a coma, releasing gas, and cruising through the solar system without drama. Some people feared Borisov could collide with Earth or disrupt planetary orbits. But it flew by smoothly, boring even, like a guest who followed every house rule. Borisov reassured scientists that interstellar objects could be predictable. 3I Atlas shattered that calm and showed us they could quietly undermine confidence without causing harm. Apophis now stands as the ultimate test run. Scientists already know it won't hurt us, but then again, the examples of interstellar visitors show how little we actually know about them. It indicates that space has its own, mostly unknown rules, is highly hostile to human life, and it's not very polite either. It doesn't announce surprises in advance, and the better we know about it, the better we can be prepared for these surprises. Well, the space object 3I Atlas just whipped past the sun, and instead of clearing things up, the new images made everything even stranger. Because if this thing really is a comet, then it's the strangest comet ever recorded. And if it's not a comet, then we're watching something completely new invade our solar system. So, should we be worried? This all started back in July 2025. Astronomers using the Atlas Survey telescope in Chile spotted a faint, super fast-moving object, something unlike anything they'd seen before. That was our first look at 3I Atlas, and right away, scientists had a lot of questions. Where did it come from? What's it made of? But more importantly, what is this thing? At first glance, it almost looks like a tiny cell, right? Like something you'd see under a microscope, with a bright center like a nucleus, and this fuzzy outer layer. But when we look at it from a different angle, the mystery clears up. That glow is actually a comet tail. It's precisely because it looks like and behaves like a comet that NASA finally confirmed it. Yup, 3I Atlas really is a comet. The big giveaway is that it has an icy nucleus and a coma, which is that glowing cloud of gas and dust surrounding it. But this comet is a very special one because it didn't come from our own solar system. It came from somewhere else in the Milky Way, and that's ridiculously rare. To give you an idea, we've only ever seen 3 objects like this, period. The first 2 interstellar visits were the famous Oumuamua and the comet Borisov. And now, 3I Atlas. Cool. But you might be asking, how do we know it actually came from outside our solar system? You see, normal comets are bound to the Sun. They swing around it in these big looping orbits. But 3I Atlas isn't doing that. Its crazy speed and path show it's not on a closed orbit around the Sun. And the only logical explanation is that it came from another star system and, just wandered into ours by chance. In other words, this is just a visitor passing through our solar system, and is doing it at a ridiculous speed. When we first spotted it, it was going around 137,000 miles per hour. So this object probably spent millions of years cruising through deep space just to hang around our solar system for a few months. And after this quick visit, it'll vanish into interstellar space, and we'll never see it again. Recently, 2 European Space Agency satellites, along with several NASA spacecraft near Mars, captured new images of 3I Atlas zooming in as it passed the red planet. And one of those images is pretty incredible, showing a cloud of hydrogen atoms around the comet. Scientists were pretty excited about that, as every bit of information we get from this visitor matters. Because the reality is, there are still a lot of unanswered questions about this object, starting with its size. We can't pin it down exactly yet, but NASA says it could be anywhere from about 1,400 feet to around 3.5 miles in diameter. Its exact shape is another mystery, because our telescopes can't really get a clear look at it. The nucleus is buried inside this bright coma of gas and dust, and the sunlight reflecting off all that dust basically blinds us. So for now, we're trying to see it through a bright, dusty fog. If you put all the pieces together, its behavior, its chemistry, and the images we've gotten so far, everything points to 3I Atlas being a comet. But even with all that, there are still some pretty controversial ideas floating around about what it might be. Not long after it was discovered, Harvard astrophysicist Avi Loeb said there's maybe a 30 to 40% chance this object isn't something naturally formed. That comment kicked off a wave of online buzz, with people jumping to wild possibilities. Like maybe it's some kind of extraterrestrial tech, or worse, a threat to Earth. Ooh. According to this theory, 3I Atlas might be a massive extraterrestrial mothership. Its odd trajectory could mean it's sending out little satellites toward Jupiter to collect intel for some extraterrestrial civilization. So, in that version of the story, this isn't just a comet. It's basically advanced space spy tech. But then the obvious question is, why spy on Jupiter, right? I mean, wouldn't Earth be way more interesting to an interstellar civilization? Well, in this theory, Jupiter is the target because it's so much bigger than Earth and the other neighboring planets. The idea that a planet that massive could act kind of as an interstellar beacon, something that stands out from far away. The region near Jupiter is another big reason. It's almost like it's an ideal parking spot, where space technology could basically hang out, without using much fuel at all. In other words, if you were going to place advanced satellites somewhere to watch a planet, well, that's prime real estate. Pretty cool, huh? But as fun as that theory is, we gotta come back down to Earth for a second. According to the major space agencies, this thing is a comet, case closed. But that label doesn't make it any less special. 3I Atlas is still a total weirdo in the best way, and it stands out for a bunch of reasons. Let's look at 3 of the most important ones. First, this object is old, like really old. Older than me. Scientists think it's been traveling through space for at least 7 billion years. That's so far back in time that it was formed before our Sun and Earth even existed. So yeah, it's probably the most ancient thing we've ever seen in our cosmic neighborhood. Second, its glow. Comets can sometimes look kinda green, and here's why. When a comet gets closer to the Sun, the ice inside it heats up and starts releasing gas. I know the feeling. Some of that gas is made of carbon-based molecules, especially one called diatomic carbon, or C2. When sunlight hits those molecules, they light up, and to us, that glow shows up as green. But with 3I Atlas, that green color is, well, confusing. The data suggests that this comet is actually low on those carbon chain molecules. So, the big mystery is, if it doesn't have much C2, how is it glowing green at all? Well, nobody knows. And now, the third thing that makes this comet stand out. It seems to be giving off a metal alloy we've basically never seen in nature. So this comet is releasing a plume that contains nickel. That's normal. What's strange is what's missing: iron. In comets, nickel and iron usually show up in pretty similar amounts. Here, we're seeing nickel, but no clear sign of iron. And that's almost unheard of. If the data holds up, it points to an alloy called nickel tetracarbonyl, something we've only ever seen before in human-made industrial processes, not out in space. No other known object has shown this kind of signature. Well, now that you're familiar with 3I Atlas, we gotta answer the biggest question of all. Is it a threat to us? Good news! No, the comet isn't dangerous, and it's going to stay really far from Earth. So we can all take a deep breath. Well, I feel better. Although it's harmless, tracking it has been super valuable for planetary defense. You see, space agencies are always watching asteroids and comets, running the numbers on their orbits, and making sure we'd get a warning if something ever did head our way. But 3I Atlas gave them something new to practice with. This is the first time tracking data from spacecraft orbiting another planet were officially submitted to and accepted by the Minor Planet Center. That's the big global database where asteroid and comet observations get collected and checked, so scientists everywhere can stay on the same page. So, in a way, 3I Atlas was like a rehearsal. Gathering data like this from a totally new setup helps researchers sharpen their methods and improve how we spot future space objects. And that means better detection, faster tracking, and more readiness, just in case the next visitor isn't quite so friendly. Uh-oh. A mysterious space visitor has recently passed its closest approach to Earth, flying by at a distance of 64 million miles. It might be something totally natural and born on the outskirts of the solar system. Or some unknown civilization could be examining us from above right at this moment. This new object looks a lot like another strange wanderer called 3I Atlas, and you'll understand why we say strange pretty soon. So, could both of them come from the same place outside our solar system? What we do know is that this new object is relatively close to us, in space terms of course, and scientists are now studying it closely. They first spotted it inside our solar system, and people are paying attention because it showed up not long after 3I Atlas passed near our Sun. On November 2, 2025, astronomer Gennady Borisov, the same person who discovered interstellar comet 2I Borisov in 2019, found this new object. It's now got its official name and is listed in NASA's and the Minor Planet Center's databases. C2025V1 has some unusual features. Its orbit is tilted 113 degrees, which means it's moving almost up and over the regular path that planets take. Even more bizarre, its orbital plane is almost at a right angle to the path of 3I Atlas. Plus, it doesn't have a clear comet tail, which is odd. Right now, its orbit has an eccentricity of 1.0095. And let me break it down in human language. If that number was well above 1, it would mean the object definitely came from outside the solar system. But because it's only just a bit above 1, the most likely explanation is that C2025V1 came from the Oort cloud. That's a giant faraway shell of icy objects that surrounds the solar system. Now, scientists check this by basically rewinding the object's path, sending it all the way back to about 1000 AU. That's 1,000 times farther than the Earth is from the Sun. At that huge distance, the planets can't mess with its motion anymore. When they redo the orbit from that point, its eccentricity, the number that tells you if it's from outside the solar system, usually drops below 1, which means it's still part of our solar system. But at the same time, even a tiny push from Jupiter while passing by could make even a normal Oort cloud comet look like it has an eccentricity slightly above 1. And on top of that, small blasts of gas coming off the comet's surface can also change the numbers a little. So, to put it simply, it probably isn't interstellar. It just looks that way because of small pushes and gas bursts. C2025V1 is still exciting, even if it comes from the Oort cloud, because studying it gives us a chance to analyze the material from that distant region and learn how our solar system formed and evolved. Now, let's get back to the mystery of 3I Atlas. Before anything else, let's explain what 3I Atlas actually is. It's most likely a comet, basically a huge, dirty snowball flying through space. You can't see it with your own eyes or with a regular telescope. But there's good news. A powerful telescope in Italy is streaming it live for free. So anyone can actually watch this mysterious object as it passes by. Scientists think this comet weighs about 33 billion tons. That number is hard to imagine, so here are a few comparisons. The Eiffel Tower weighs around 10,000 tons. So 33 billion tons is the same as a whopping 3.3 million Eiffel Towers. And if you decide to compare the space visitor to buildings, 33 billion tons is about the same as the weight of several huge city areas made entirely of steel and concrete. But even all that size isn't the wildest part. Some experts think this object might be a piece of unknown technology from outside our galaxy. And they're not saying this just for fun. There are real reasons behind the theory. 3I Atlas was first noticed in July by NASA's Asteroid Terrestrial Impact Last Alert System, or ATLAS. Shortly after, NASA confirmed that the object wasn't from our solar system at all. It's an interstellar object, only the third ever discovered. The first one was Oumuamua in 2017, which looked long and flat and didn't behave like a normal rock. The second was Comet BI Borisov in 2019. Now we have 3I Atlas, and it is enormous compared with the other two. Its nucleus is up to 3.5 miles wide, while Oumuamua was only about a quarter mile long, and Borisov was around a half mile across. Besides being huge, 3I Atlas is unusual in several other ways. As it moves through the solar system, it's releasing massive amounts of carbon dioxide and gas. This suggests that 3I Atlas is 3 to 5 orders of magnitude, which means 1,000 to 100,000 times more massive than the other two known interstellar visitors. Such an enormous difference is a real scientific mystery. It's also traveling incredibly fast, about 150,000 miles per hour, which is almost 200 times the speed of sound. And unlike objects in our solar system, which followed curved paths because of gravity. 3i Atlas is moving on a nearly straight line. That alone makes it stand out. These odd behaviors have led some researchers to consider a pretty unexpected idea. 3i Atlas might be a probe sent by another civilization, possibly to study Earth. According to this theory, the object could be a sign of some kind of intelligence from beyond our solar system. Why do they think this? Well, because the object's movement doesn't match what you'd expect from something controlled only by gravity. It also passes close to Venus, Mars, and Jupiter, and these are the planets that might be especially interesting for an outside civilization to observe. Another very unusual feature of 3i Atlas's path is that its orbit is tilted only a little compared to the plane of the solar system, about 5 degrees, and it moves in the opposite direction to most planets. This feature might allow the object, or its creators, to take extremely precise measurements of planets, things like their orbits and sizes, to plan a perfect flight route through the solar system. And if 3i Atlas suddenly changes direction at some point, that could mean it's using a built-in engine instead of simply drifting through space. Now, new photos have also shown that 3i Atlas has at least 7 jets blasting material into space, some shooting in totally opposite directions. Now, if this thing is just a normal comet, it would have had to lose a huge amount of its original mass when it passed near the Sun, way more than just 10 to 20%. Only some of that material would actually push the object in one direction, so the total amount blown off would need to be massive. If that's what happened, then there should be now a giant cloud of gas and dust around 3i Atlas. And if that cloud exists, it'll be pretty easy to figure out what the comet is made of. The James Webb Space Telescope will check this when 3i Atlas gets closest to Earth on December 19, 2025. But if 3i Atlas is not a normal comet and is actually some kind of technology, it wouldn't need to lose that much material. Engines built by an advanced civilization could give it a boost while using way less gas because they shoot it out way faster. Faster exhaust gives more push with less fuel, so a technological object wouldn't need to blast away big chunks of itself the way a natural comet would. So, to sum it up, there's still a big mystery around 3i Atlas. Could it really be a technological mothership that released small probes into the inner solar system? But C2025 V1 doesn't fit that idea, unless one of the objects used some kind of engine. The closest their orbits ever come is about 46 million miles, and the two objects themselves were never closer to each other than about 140 million miles. The tiny non-gravitational push detected in 3i Atlas is nowhere near strong enough to close this gap. So, C2025 V1 is almost certainly not one of the many probes people imagine 3i Atlas might have released. A large space probe is nearing the Sun. The terrifying heat of the star begins to melt the shell of the spacecraft. Another moment, and the probe bursts into flames. In no time, it disintegrates in a powerful explosion. Ah, what a sad ending. If it were true, it was not a probe. It was a comet known as 3i Atlas. And despite everything people say, it's still intact and thriving. The thing is, there is a rumor online saying that comet 3i Atlas exploded when it got closest to the Sun. But astronomers say this is not true. There was no explosion, and the comet's nucleus still looks whole and undamaged, which is kind of surprising, since comets that pass very close to the Sun usually go through some serious changes. You see, comets are made of a mix of ice, dust, and rocky material, which is why they're often called dirty snowballs. So, when they come close to the Sun, the intense heat from our star makes their ice turn into gas. This new gas can burst out in huge jets, form a cloud around the comet called a coma, and/or be pushed away into a long tail. Sunlight makes all of these parts shine more brightly, and even people with small or simple telescopes can study the comet if the viewing conditions are good. But aside from being a breathtaking view, such a close approach can break off pieces of a comet or even tear its whole nucleus apart. Now, it's true that some comets survive this process, but many, especially small ones, or comets entering the inner solar system for the first time, break into pieces or disappear completely. Well, 3I Atlas acted differently. So there. It reached its closest point to the Sun on October 29, 2025. This point is called the perihelion. At that moment, the comet was about 130 million miles from the Sun. That's about 1.5 times the distance between the Sun and our planet. The comet was also on the opposite side of the Sun from Earth, so the star was blocking it from our view and we couldn't see the comet. Anyway, even though 3I Atlas could hypothetically break apart or release lots of fragments, it didn't. The nucleus stayed intact, and this made the comet's behavior even more unusual and interesting to scientists. They looked closely at the new photos and said everything looked normal. Now, interestingly, the day before, some people thought the comet had broken into pieces after it came out from behind the far side of the Sun. This idea became popular after a blog post said the comet had lost a lot of mass. So, to make this claim, the blog used photos taken on November 9th by 2 small telescopes in Spain. The pictures show jets of gas coming out of the comet. The scientists used this to estimate how much material was coming off the comet, claiming that it should have broken into at least 16 pieces. However, many scientists have questioned this statement. Most researchers say there's no proof that the comet exploded. One scientist who studies the comet says that all the images he had seen showed a completely normal, healthy comet. There's no sign that the main body of the comet has broken apart. Still, now that the comet is coming back into view, astronomers are watching it very carefully. They want to learn more about the comet's materials and structure. Right now, if you look at it from Earth, the comet seems to be slowly moving higher in the eastern sky. If the weather is good, people in many parts of the northern hemisphere can see it with a small telescope, like this one with a 6-inch lens. And many do pay attention to the comet. Since it was discovered in July, it has become the center of many curious ideas. Some people are sure that the comet, which comes from outside our solar system and might be more than 7 billion years old, could be a probe sent by a different civilization. Now, most astronomers strongly disagree, of course. They believe the comet is completely natural and comes from another star system somewhere in the Milky Way. And this is actually exciting. Comet 3I Atlas is only the 3rd interstellar comet ever seen, and it is the largest one of its kind. Before, it was Comet 2I Borisov that passed through in 2019, and Oumuamua, a weird elongated object that appeared in 2017. But 3I Atlas, with its up to 3.5-mile nucleus, dwarfs Oumuamua, which was just a 1/4 mile long, and Borisov, which is about 3/10 of a mile across. Plus, 3I Atlas may be the oldest comet humans have ever observed. Oumuamua is much younger, around 1 billion years old. It came from the galaxy's thin disk, where new stars are still being born. It was the first known object from another star system to pass through our solar system, basically our first interstellar guest. It was super stretched out, about 10 times longer than it was wide, unlike anything else we've spotted in space. As for 2I Borisov, it sits in between, at roughly 1.7 billion years old. It also came from the thin disk. It was the first confirmed comet to come from another star system, and it gave scientists a super rare peek at what materials beyond our solar system were made of. Unlike the first interstellar visitor, Oumuamua, which looked more like an asteroid, Borisov behaved like a classic comet. It had a bright coma, a temporary fuzzy atmosphere of gas and dust forming around the comet's nucleus as it approaches the Sun. Plus, it also had a long tail of dust and gas. Now, 2I Borisov is speeding away from the Sun and will never return. But it allowed scientists to take a glimpse into the chemistry and history of distant worlds. Now, let's get back to Comet 3I Atlas. It will pass closest to Earth on December 19th. Until then, scientists will make many more observations. People will also make many new claims about the comet, that's for sure. But it's best to be cautious and not believe everything immediately. By the way, even though you can't see this famous comet with your own eyes or with a regular telescope, hey, that's good news. A powerful telescope in Italy is streaming it live for free. Whoa! So anyone can actually watch this mysterious object as it passes by. Scientists think this comet weighs about 33 billion tons. That's a big number. How about we make a few comparisons? The Eiffel Tower weighs around 10,000 tons. So, 33 billion tons is the same as 3.3 million Eiffel Towers. And if you decide to compare the space visitor to buildings, well, 33 billion tons is about the same as the weight of several huge city areas made entirely of steel and concrete. Now, 3I Atlas was first noticed in July by NASA's Asteroid Terrestrial Impact Last Alert System, which, if you're paying attention, is where they got the nickname Atlas. Shortly after, NASA confirmed that the object wasn't from our solar system at all. Now, besides being huge, 3I Atlas is unusual in several other ways. As it moves through the solar system, it's releasing massive amounts of carbon dioxide and dust. So this suggests that 3I Atlas is 3 to 5 orders of magnitude, which means 1,000 to 100,000 times more massive than the two other known interstellar visitors. Such an enormous difference is a real scientific mystery. It's also traveling incredibly fast, about 150,000 miles per hour, which is almost 200 times the speed of sound. Hey, that will get you a speeding ticket. And unlike objects in our solar system, which follow curved paths because of gravity, 3I Atlas is moving on a nearly straight line. That alone makes it stand out. Now that the comet has moved past the Sun, telescopes on Earth can see it again. Comet 3I Atlas is important to us because it's only the third interstellar visitor we've ever seen, and it may be the biggest and oldest one yet. And it didn't break apart near the Sun like some other comets. By studying it, scientists can learn what materials exist in other star systems and better understand how comets, and even planets, form in our galaxy.
Comet 3I Atlas crashes into Earth, and a wave of widespread destruction starts shaking our planet. Ginormous tsunamis are swallowing coastlines, devastating earthquakes are cracking the ground. Hot debris is igniting massive firestorms. Thick clouds of dust are blocking the sun. Now, that's what could happen if 3I Atlas, a massive comet traveling through the solar system, collided with our planet. But can this disaster actually occur? When will 3I Atlas be the closest to Earth? Let's figure this out. First of all, this comet turned out to be way larger than we previously thought. Its weight is likely a whopping 33 billion tons. Let's throw in a few comparisons to put it into perspective. The Eiffel Tower weighs about 10,000 tons. So, 33 billion tons is roughly the weight of 3.3 million Eiffel Towers. Impressive! Next, all the cars on Earth, and we're talking about 1.5 billion vehicles, each weighing about 1.5 tons, weigh approximately 2.25 billion tons. This means that the comet's mass is 15 times greater than the combined weight of literally all the cars on the planet. And finally, compared to buildings on Earth, 33 billion tons is equal to several large metropolitan areas made entirely of steel and concrete. But the whole idea of how big this comet is fades in comparison with an even crazier fact about it. It could be unknown technology from a different galaxy, and some experts are somewhat sure about that. But why? 3I Atlas was first spotted in July by NASA's Asteroid Terrestrial Impact Last Alert System. A bit later, the US Space Agency confirmed that the object was an interstellar object, only the third we have found so far. Before, it was Comet 2I Borisov that passed through in 2019, and Oumuamua, a weird elongated object that appeared in 2017. But the newest comet, with its up to 3.5-mile nucleus, dwarfs Oumuamua, which is just a quarter mile long, and Borisov, which is about 0.6 miles across. By the way, some believe that the comet could be even bigger, up to almost 7 miles, but scientists haven't found any proof of that yet. Besides its size, 3I Atlas is different in other ways too, which makes some scientists question its origins. The object is shedding huge amounts of carbon dioxide and dust while zooming towards the Sun. It's most likely the proof that 3I Atlas is more massive than the other two interstellar objects by 3 to 5 orders of magnitude, which is basically a serious anomaly. The comet is also traveling toward the Sun incredibly fast. We're talking about around 130,000 miles per hour, which is almost 170 times the speed of sound. Another weird thing is that this interstellar object is following a straight trajectory, unlike anything else in the solar system. Most space bodies move along curved orbits due to the force of gravity. That made some researchers believe that 3I Atlas might be a probe sent by another civilization to explore Earth, possibly with not-so-friendly intentions. Their theory is that the object could be a technological artifact, a sign of cosmic intelligence. You see, the comet moves in a pretty weird way that doesn't totally line up with just gravity. Its trajectory also takes it close to Venus, Mars, and Jupiter. And researchers think that these planets might be especially interesting for another civilization to pass by. Another bizarre fact, the space traveler also spins backward compared to most stuff in our solar system. This might be necessary to make it easier for 3I Atlas to get near Earth without much resistance. Some scientists think the comet's odd spin and flight path could help whoever or whatever made it take super precise measurements of the planets, things like their orbits and sizes, to plan a perfect route through the solar system. If 3I Atlas suddenly changes direction in a big way, that might mean it's using some kind of built-in engine instead of just drifting through space. There's also another theory that suggests it could be a piece of unknown tech that's still active. There's no need to worry though, at least at the moment. The comet isn't coming anywhere near us. NASA says it'll stay around 150 million miles from Earth when heading toward the Sun. So the question is, where do such space visitors come from? Astronomers have found that the 3 interstellar objects we discovered came from totally different parts of the galaxy. And each of them has its own age and background. 3I Atlas turned out to be the oldest, about 4.6 billion years old, and it came from the Milky Way's thick disk. That's a region filled with older stars that have fewer heavy elements. 1I Oumuamua is much younger, around 1 billion years old. It came from the galaxy's thin disk, where new stars are still being born. Oumuamua, Hawaiian for a messenger from afar arriving first, was the first known object from another star system to pass through our solar system. Basically, the first interstellar guest. It was super stretched out, about 10 times longer than it was wide, unlike anything else we've spotted in space. It also sped up in a way that couldn't be explained by gravity alone. Changes in brightness showed it was tumbling end over end instead of spinning smoothly. At first, scientists were confused because the space body didn't have a tail or cloud of gas like a normal comet, even though it was accelerating. That led to a lot of debate about what it was made of and where it came from. Just like with 3I Atlas, some people wondered if it could be technology created by a space civilization. But most scientists now think Oumuamua was a totally natural object, just a really weird one. The best guess is that it was a comet releasing invisible hydrogen gas, which caused it to speed up slightly. Sadly, by the time astronomers found it, it was already heading out of the solar system, so there wasn't much time to study it. As for 2I Borisov, it sits in between at roughly 1.7 billion years old. It also came from the thin disk. It was the first confirmed comet to come from another star system, and it gave scientists a super rare peek at what materials beyond our solar system were made of. The comet was discovered in 2019 by Gennady Borisov, an amateur astronomer who actually built his own telescope to search for faint space objects. Unlike the first interstellar visitor, Oumuamua, which looked more like an asteroid, Borisov behaved like a classic comet. It had a bright coma. That's a temporary fuzzy atmosphere of gas and dust forming around the comet's nucleus as it approaches the Sun. Plus, it boasted a long tail of dust and gas. Studying 2I Borisov helped researchers learn more about how other planetary systems form. Observations showed that its dust grains were compact and that the amount of gases like carbon dioxide changed a lot as it approached the Sun. It could mean that the comet formed under very different conditions than anything else in our solar system. Now, 2I Borisov is speeding away from the Sun and will never return. But it allowed scientists to take a unique glimpse into the chemistry and history of distant worlds. Interestingly, the differences between these three space objects suggest that interstellar visitors have been getting kicked out of planetary systems all across the galaxy for billions of years, so it's not something new. To figure out if 3I Atlas might be some kind of probe from another planet, scientists are checking for any signs of technology, like strange radio signals, electric activity, and weird movement patterns. If the comet suddenly changes course or drops smaller objects nearby, it might be our cue. But even though 3I Atlas is moving in a pretty wild and energetic way, it's most likely just a natural interstellar object passing through. Researchers say they'll need a lot more proof before anyone can seriously say the space wanderer was sent by someone from another planet. What do you think about this newly discovered space traveler? Share your opinion in the comments.
Some people, like the Andaman Islanders, that's a community living in the Gulf of Bengal, see them as burning torches thrown into the air by forest spirits. Others, like some Australian Aborigines, think they're flaming sticks ridden by shamans. If you ask an astronomer, though, they'll tell you that a comet is a large object made of dust and ice that orbits the Sun. Arguably one of the most famous space objects of this kind is Halley's Comet. It has left a great impact on our history and understanding of these mysterious falling stars. When this comet passed Earth in August of 1835, for example, it was blamed for the New York City fire that kept going for several nights. At the same time, the Seminole Indians in Florida saw the comet's long tail and believed it marked the day they would lose their independence. This comet came back in 1910, and people yet again saw it as a sign of bad luck. In Chicago, people bent over backward to secure their windows to protect themselves from the comet's dangerous tail. Others bought all sorts of gadgets, like umbrellas or masks protecting from comets. But what's so intriguing about this space body? How come it just pops up around Earth every once in a while? And, most importantly, is it really dangerous? Halley's is what astronomers call a periodic comet. It visits us every 75 years or so. On rare occasions, some lucky people get to see it twice in their lifetime. It last passed Earth in 1986, and it is expected to come back in 2061. Despite this scheduled return, the comet's orbit can't be predicted with precision. That's partly because of the chemical processes happening inside the comet. Halley's orbit may also change due to random interactions with other planets and space objects in our solar system. Its official title is 1P/Halley, and it's named after English astronomer Edmund Halley. He was the one who studied the reports of a comet nearing Earth in 1531, 1607, and 1682. Based on his calculations, he concluded that these three occurrences had been, in fact, the same comet, returning over and over again. He also predicted its return in 1758. Halley's discovery also pointed out that some comets, like this one, orbited the Sun, but their journey was not circular. If you look at it in 2D, Halley's orbit looks like an elliptical wire dangling from the sun. Sadly, Halley didn't live to see the comet's correctly predicted return, but it was named after him. According to the European Space Agency, the first sighting of Halley's comet dates back to March 30th, 239 BCE. Asian astronomers noted it down in the Sheqi and Wenxian Thungkao chronicles. But another study claims that we might have first noticed it even earlier than that, during the times of the ancient Greeks. Writings from that period reported a huge meteor that landed in northern Greece, leaving the local population perplexed. It soon became one of the ancient world's most popular tourist attractions. But the authors also noticed a comet in the sky at the time the meteor landed. They also reported the fact that the unusual space object had remained in the sky for about 75 days. Shakespeare himself seems to have written about this comet in his play Julius Caesar around the year 1600. In this work, he included a now famous phrase speaking of comets as unusual signs, saying, "The heavens themselves blaze forth." It wasn't the last time famous writers felt a certain connection with this object. Writer Mark Twain even said in 1909, "I came in with Halley's Comet in 1835. It is coming again next year, and I expect to go out with it." Surprisingly, Twain passed away on April 21st, 1910, one day after Halley's had emerged from behind the far side of the sun. We got a better look at the comet when it last passed us in 1986. Several spacecraft were sent toward Halley's to take samples of the comet's composition. This fleet of spaceships, dubbed the Halley Armada, flew nearby, one of them taking several pictures of the comet's core for the first time in history. We also had much better telescopes to look at the comet as it swung by our planet this time. Based on current studies, there's little to no chance that Halley's Comet could actually pose any danger to our planet. Most of the bad things associated with the comet were just fabrications. Even better, comets, in general, may have made life on Earth possible. Specialists believe that early in our planet's history, collisions with comets brought a significant amount of water here, which helped to form our oceans. These space objects may have also gifted us organic material necessary for the formation of life. Don't confuse comets with asteroids, though. Unlike asteroids, which are small rocky space bodies also orbiting the sun, comets are mostly made up of frozen ammonia, methane, or water. They contain only small amounts of rocky material. Because of their composition, comets are sometimes nicknamed dirty snowballs. Comets are made of 4 parts: a nucleus, a coma, a dust tail, and an ion tail. But their nucleus makes up most of their total mass. There are over 3,000 comets that we know of, but astronomers think there may be up to 1 billion of them in our solar system. A comet that is bright enough to be visible from Earth without the help of a telescope is called a great comet. Approximately 1 great comet can be seen every 10 years or so. People have noticed other comets for millennia. However, scientists have concluded that since comets shed a lot of material each time they orbit close to the sun, their lifespan may be only thousands of years. If you compare that to the age of the solar system, which is 4.6 billion years, it's a relatively small number. Since these space bodies are still present in the solar system today, there must be a source of comets somewhere out there. Otherwise, all comets would have disappeared a long time ago. Another famous comet is named Hale-Bopp. It came very close to Earth in January 1997. The last time it was seen near our planet before that was during the Bronze Age, back in 2000 BCE. This comet is much larger and more spectacular than Halley's. Its nucleus stretches for up to 24 miles in diameter and can be seen from the surface of our planet with the unaided eye. Comet Borrelly was the second comet to be studied up close by a spacecraft. NASA's Deep Space One approached it in 2001 and gave scientists a detailed report of the comet's black core. This comet is surprisingly lopsided, but the reason for its unusual shape is still up for debate. Halley's Comet appears to have formed in the Oort cloud at the outer edges of the solar system. But Borrelly is said to come from an icy cloud of rocks beyond Neptune, which is called the Kuiper Belt. Comet Hyakutake gave us quite the show when it passed just 9.3 million miles from Earth in March 1996. It looked like an ice blue splash with a faint gas tail. This comet amazed astronomers too, as it produced X-rays 100 times more intense than scientists had predicted. A spaceship called Ulysses passed through Hyakutake's tail in May 1996, reporting that it was at least 350 million miles long. That's double the size of any other known comet's tail. The comet Wild 2 was examined by NASA's Stardust spacecraft back in 2004. The probe managed to fly within 147 miles of the nucleus of Wild 2, giving us some of the best comet pictures to date. It was also the first time we got samples of dust particles from a comet. The precious cargo came back to Earth in January 2006. Its aim was to shed light on the conditions under which Wild 2, and the solar system for that matter, formed those billions of years ago. Wild 2 is about 3 miles in diameter and covered with craters and cliffs.
Have you ever wondered why rockets are launched right next to the equator or the sea? Or why do we launch them vertically and not like airplanes? Let's answer all the possible, not stupid questions about rockets. Question 1. How does the Earth affect the rocket's launch? Let's remember some school physics. The gravity of the Earth is incredibly strong. To overcome this force, we need to develop a huge speed. Fortunately, rockets are capable of developing it, but it would be much more difficult if the Earth itself didn't help it. The Earth rotates around the Sun at a speed of 67,000 miles per hour. Very fast, to put it mildly. And we are all moving with it. So getting off the Earth is like getting out of a moving car. For some time, the rocket will move along our planet by inertia. It's like a helpful push. The rocket takes off from Earth at a certain speed already, and then it just needs to accelerate a bit more with the help of its fuel. By the way, this isn't the only scientific trick in launching rockets. To get to the maximum benefit from this push, they're launched into Earth's orbit from west to east. Why? Because the Earth rotates from west to east, of course. This way, the rocket receives maximum inertia. Question 2. Why are rockets launched next to the equator? The answer is related to the previous question. Believe it or not, the Earth's surface is moving faster at the equator. The school lied to us a little. The Earth isn't perfectly round. Rather, it's a flattened ellipse. And the equator is the widest point on our planet. Now, what is speed? It's the distance divided by time. And since the distance at the equator is the largest, about 25,000 miles, then the rotation speed there will be higher. So, imagine that you and your friend were standing at two different points of the Earth. You are at the equator, and your friend is closer to the North Pole. After standing there for the entire day, you would fly more miles than your friend, which technically means that you moved faster. So yep, the rotation speed at the equator is higher. Naturally, it's most profitable for us to launch rockets from places where the initial thrust velocity will be as high as possible. And launching from the equator causes the spacecraft to move almost 300 miles per hour faster. Question 3. How do scientists choose the places for the launch pads? Rockets are gigantic, complex monsters weighing several thousand pounds. Needless to say, dozens of errors may occur during startup. Probably the most dangerous one is a mid-flight failure. That's when something goes wrong in a rocket that's still in the sky. If the burning debris falls to the Earth, it may cause a huge disaster. Now, let's look at a map of the location of launch pads in the world. You can see that many of them are located near the coast. For example, the Kennedy Space Center in Florida, USA, or the Satish Dhawan Space Center in Sriharikota, India. That's the way to minimize and ideally eliminate altogether the risk of debris falling on your head. If something goes wrong during the launch, it will fall into the ocean waters, far from densely populated areas. And yeah, there are a bunch of launch pads located far from the sea. That's because many other things also play a role in choosing the location. For example, the availability. The launch pad should be ideally accessible from land, air, and sea. Question 4. Wait, doesn't Florida have crazy weather? Why did they choose this state? For more than 70 years, NASA has been launching rockets from Cape Canaveral, Florida. It's because Florida has a very humid and tropical climate. There are more thunderstorms a year than in any other place. This can greatly interfere with rocket launches. It's very dangerous. Moreover, one time it actually happened. In 1987, lightning struck an AC-67 rocket before takeoff. Its systems failed and eventually the rocket was destroyed. Fortunately, there were no people on board. Another big weather threat is hurricanes. And yes, they also happen in Florida more often than in any other state. But despite all this, NASA still chose this cursed place to launch their rockets. Why? Well, probably because all the crazy things, including rocket launches, must happen in Florida. But on a serious note, before NASA moved to Cape Canaveral, rockets were launched from another place. From the White Sands test site, located in New Mexico. Back then, since White Sands was located in a remote area of the country, everything was more or less safe. If the rockets had fallen, they wouldn't affect or destroy anything. But as time went on, our technologies developed. The rockets got bigger and needed much more space for their launches. As a result, the danger zone also increased. White Sands was just 26 miles from Las Cruces, New Mexico, and 70 miles from El Paso, Texas. In other words, it was surrounded by settlements. Therefore, scientists began to look for safer places. The East Coast seemed like the best option. Can you guess why? Not only is the East Coast closer to the equator, but it's also located near the Atlantic Ocean. We already know that this actually adds +1 to the security. That's why in the 1950s, NASA moved its launches to Florida. The first one was the launch of the Bumper 8 rocket, which took place on July 24, 1950. And then, this place became a full-fledged spaceport. Question 5. Why are rockets launched vertically? Rockets are thin, cylindrical tall things that go into space vertically and leave behind a giant cloud of smoke. But why are they launched that way and not like airplanes, for example? Well, this sounds a bit crazy. To implement it, we'd have to make a lot of changes to the current rocket designs. But the most important thing is that it would waste a lot of resources. This may surprise you, but planes and rockets are designed a little differently. The plane's main task is to fly in the atmosphere. The rocket's main task is to leave the atmosphere as soon as possible. Due to the air resistance in the sky, the rocket loses most of its energy while flying. Therefore, we need to make sure that it has left the Earth's atmosphere before its fuel is completely used up. And since it needs a lot more fuel than an airplane, it's easier and more economical to launch it straight up. So it will use a minimum of fuel, just what it takes to kick gravity in the face. Question 6. Why does the trajectory of a rocket change after launch? Remember that we said that the rocket's main task is to escape gravity by any means and reach space? Now forget about it. Technically it's true, but it doesn't show the full picture. The very task of getting into space isn't particularly difficult. The space isn't actually that high. You'll officially become an astronaut if you go to an altitude of about 60 miles above Earth. But it's all about staying in orbit. The orbit is the boundary of two worlds. Here, the gravitational pull of the Earth is still large enough that the rocket doesn't fly into outer space, but at the same time, low enough that it doesn't fall back to Earth. So, if you reach it, there's no need to waste fuel anymore. The spacecraft will simply fly in zero gravity by inertia. If the rocket flies purely in a straight line, it will simply fly into outer space. To enter orbit, it needs to fly in an arc. Therefore, after starting, it begins to tilt to the side and gradually increases this slope. Getting into orbit is a very difficult task, actually. The fuel should be enough to reach an insane speed of 18,000 miles per hour. That's why we invented this optimization method. Smart people call it gravitational reversal. So a rocket bends its trajectory after launch because it has to go into Earth's orbit. Congrats, that was a long journey. But now you, hopefully, learned a bit more about rocket launching.
Whew, okay, big relief. 2024 YR4 isn't going to hit Earth and wipe out entire cities. But this huge asteroid could still hit the Moon by 2032. The impact could blast a massive cloud of dust and debris into space, putting satellites and astronauts at risk. So NASA is now considering a bold Armageddon-style solution to blow it up. This asteroid was first discovered back in 2024, thanks to the Atlas Survey Telescope in Chile. Now, its official name is 2024 YR4, but hey, let's just call it Nugget for short. So, Nugget is huge, about 200 feet across, which is like a 15-story building. If something that big hit Earth, it would be catastrophic. It could wipe out major cities like London, Paris, or New York, and if it hit the ocean, it could trigger massive tsunamis. Now imagine the scientists' surprise when they ran the numbers and realized that, wait, there's a real chance it could hit Earth. And at one point, the odds were about 3%. Now, that doesn't sound like much, but with city-destroying potential, you want that number at 0, right? That's how this big guy became the first asteroid to trigger a coordinated international planetary defense response. Thankfully, by March 2025, space agencies had enough data to rule out an Earth impact. In fact, there's no serious threat from this asteroid for at least the next 100 years. So that's the good news. But then a new problem showed up. It might hit the Moon. New projections say there's a 4% chance that it could hit our natural satellite in December 2032. The scary part is that the odds might actually be higher, maybe a lot higher, and we might not know for sure until there's barely any time left to do anything about it. Because right now, Nugget is simply too far away to study any further. It's hidden from our view, and scientists say we won't be able to spot it again until June 2028. And only then will space agencies be able to take new observations and confidently figure out whether the asteroid will, or much more likely, won't hit the Moon. But what if they actually find out that Nugget is actually on a collision course? I mean, should we intervene? Well, some scientists think we should. After all, it could still be dangerous for astronauts, and it could even knock out stuff we rely on down here, like the internet, cell service, and GPS. If this asteroid did collide with the Moon, the impact would be so huge that it would likely be visible from Earth. But honestly, no one knows what exactly would happen, and there's a reason for that. When small space objects hit Earth's atmosphere, they usually burn up. But the Moon doesn't have that kind of shield, so it gets smacked all the time by asteroids and meteorites. Estimates show about 100 space rocks hit it every single day, and most are tiny, basically the size of ping pong balls. But an asteroid the size of Nugget is a whole different story. Actually, it's really rare for something that big to hit the Moon, and it only happens about once every 4,000 to 5,000 years. And it's even rarer that we know about it ahead of time. So, scientists will probably run a lot of detailed computer simulations over the next few years to see what might happen. But they're already pretty sure the impact would leave a brand new crater on the Moon, roughly 3,000 feet wide. And right after Nugget hits, the blast would kick up a massive spray of regolith into space. By that, I mean the dust and small rocks covering the Moon. The problem is, we wouldn't be able to predict ahead of time exactly how much material would get launched into space, or whether any of it would reach Earth. Some say the number of tiny space rocks hitting us could jump to 1,000 times the usual level, and that could last for a few days. On the bright side, an event like this could turn into one of the best meteor showers ever. But here's the problem. It wouldn't just look cool. It could be really dangerous for astronauts on the ISS and other space stations. It could mess with satellites and turn into a real headache for all of us down here. And yeah, we definitely don't want that. So, scientists are working on a plan to make sure Nugget doesn't hit the moon at all. And when it comes to stopping a collision like this, there are really only two options: deflect the asteroid or destroy it. Ideally, you just want to deflect it. The idea is to give this asteroid a little push so it changes its trajectory and doesn't hit the moon. And the earlier you do it, the smaller that push has to be. But this method comes with a catch. To deflect Nugget accurately, we first need to know how much it weighs. And that's harder than it sounds, because estimates of its mass depend on its density, which is tough to figure out from that far away. The asteroid could weigh anywhere from 51 million to over 711 million kilograms. And depending on where it falls in that range, the energy needed to nudge it the exact right amount could be completely different. And the problem is that if a deflection mission is based on the wrong mass estimate, you could accidentally nudge it the wrong way. That could make the problem worse, including, in the worst-case scenario, redirecting it toward Earth. So yeah, maybe we should just drop that idea. And scientists basically agree. Which brings us to option number 2, destroy it. Now, there are two ways to do that. The first is using kinetic energy. Basically, you hit it with something big and heavy enough to break it into smaller chunks. We've actually seen this kind of idea work. NASA's DART mission showed that, yes, you can change an asteroid's trajectory by crashing a spacecraft into it. But crashing into a huge space rock with the real goal of destroying it? Well, that's a whole different level of difficulty. Maybe we'll have the tech to do that by 2030, maybe we won't. The second way to destroy an asteroid is something called a height of burst. So basically, you set off a nuclear device close to the asteroid, just above the surface. NASA studies say a 1 megaton nuclear blast would be enough to destroy Nugget, no matter what size or how heavy it is. We have never actually tested a nuclear detonation in space specifically to deflect an asteroid before, but the physics says it can work. So at this point, it's not just a technical call, it's more like a big global decision. Authorities still need to figure out if it's worth doing all this for this particular threat. And remember, for now, there's still a 96% chance this asteroid doesn't hit the moon. So we just have to wait a few years until it comes back into view to update these numbers. All of these plans are still just possible scenarios that space agencies are talking through. And any final decision would be made over the next few years. The timing would be pretty tight though. If they want to be ready for 2032, a nuclear mission would have to launch sometime between late 2029 and 2031. Now, even if Nugget never hits anything, tracking its trajectory and thinking through how we'd stop it is still a really valuable test run for planetary defense. And keeping an eye on threats like this is only getting more important, especially as space agencies move closer to building bases on the moon, where astronauts would live and work. The United States plans to start launching regular missions to the moon before NASA eventually heads to Mars. China has similar plans too, and has said it wants to land its astronauts on the moon by 2030. That's why we need sharper tools and better prediction, so everyone can stay safe up there in the future. And hopefully, Nugget, or any asteroid like it, never becomes a threat to us. Beneath the frozen surface of Uranus's moon, Ariel, something massive may be hiding, an ocean more than 100 miles deep. That's 40 times deeper than the Pacific Ocean, and it's been sealed up under ice for billions of years, waiting to be discovered. So Uranus is this pale blue gas giant way out there, the loner planet that never gets much attention. But recently, scientists turned their telescopes and computer models toward one of Uranus's 29 known moons, Ariel. Compared to its sisters and brothers, Ariel's got quite a unique personality. When the Voyager 2 spacecraft flew by in 1986, it caught some photos showing an oddly smooth surface peppered with craters, fractures, and valleys. Those details might not sound exciting until you realize what they mean. This moon was geologically active, moving, cracking, and reshaping itself like Earth does. That's rare in the outer solar system, where most moons are just frozen popsicles, quietly spinning around their planet. When scientists studied those fractures, technically called grabens, they found something strange. The pattern of these cracks looks exactly like what happens when there's pressure building underneath the surface, like a balloon stretching before it pops. It's as if something deep inside Ariel was pushing outward, warping and breaking the crust. The most logical culprit would be a subsurface ocean, which was once warm enough to push against the icy layers above it. An ocean sealed under miles of ice, hidden for billions of years. So, how would something so far from the Sun even have liquid water? Well, Ariel's orbit isn't perfectly circular, but slightly oval, which scientists call eccentric. That means as it circles Uranus, the gravitational pull changes a little each time. The constant tugging stretches and flexes the moon's interior, creates friction, and voila, generates heat. Combine that with natural radioactive decay inside the rocky core, and suddenly you've got enough warmth to melt ice deep below the surface. So Ariel might have been making its own geothermal spa out there in the middle of nowhere. Scientists modeled its interior structure and found that the stress the tidal forces were causing could have kept liquid water stable for millions, maybe even billions of years. Even cooler, or warmer in this case, is that traces of that ocean may still exist. Ariel's icy shell shows features that look recent, geologically speaking. That means the moon hasn't been completely frozen for all eternity. Beneath those fractures, there could still be small pockets or thin layers of liquid water. And this brings up the most exciting part. Water means potential life. Every time scientists find signs of liquid water somewhere in the solar system, they start whispering that question we all secretly love. Could something live there? Sure, Ariel's no tropical resort, but remember, on Earth, we've found microbes thriving near hydrothermal vents at the bottom of our oceans, living off chemicals, not sunlight. If Ariel once had similar vents pumping heat and minerals into its ocean, it could have easily hosted its own microscopic residence. And if there was an ocean there once, it could still have salt in its interior. Scientists believe salts and ammonia could act like antifreeze, keeping the water liquid longer. So even though the surface temperatures drop to minus 351 degrees Fahrenheit, the inside could stay cozy enough for water to remain unfrozen. Now, before you start packing for Uranus, let's remember this is a moon orbiting a gas giant that's about 1.8 billion miles away from us. Visiting it isn't as simple as booking a plane ticket. Voyager 2 is the only spacecraft that's ever gotten even close, and that was almost 40 years ago. We have better photos of Mars's sand dunes than we do of most Uranian moons. So, for now, scientists rely on clever modeling, telescope data, and a lot of patience. Still, this discovery is big. For decades, we've looked at moons like Jupiter's Europa or Saturn's Enceladus as the best representatives of the ocean world category. They're icy, they have subsurface oceans, and scientists have actually detected water plumes jetting into space from them. But now Ariel joins the club. If we ever send another mission to Uranus, Ariel would be a prime target for exploration. Now, another destination worth checking out is Saturn's moon Mimas. Scientists have always thought it was just a frozen rock ball, but it might be hiding a whole ocean underneath its surface, and a future spacecraft could find it. Researchers have been mapping how thick the moon's icy crust is, and those maps help them figure out how old this ocean could be and where the ice is thinnest. That's the jackpot spot for future missions to check for liquid water. Mimas doesn't look like a typical ocean world. When you look at Europa or Enceladus, you can literally see the cracks and crevices in their icy shells. Mimas looks smooth and quiet, almost like a cue ball in space. The craters look permanent, carved in rock rather than ice. Nothing about it screams ocean world. But a few years ago, data from NASA's Cassini spacecraft started telling us otherwise. Cassini, the probe that gave us our best tour of Saturn and its moons, kept sending back info that didn't quite make sense unless Mimas had liquid water under all that ice. The more Cassini's data rolled in, the more it looked like there might be a newborn ocean hiding under 12 to 19 miles of solid ice. Scientists used models originally made for Europa to figure out how heat moves through Mimas's icy shell. They wanted to know how thick it was, how much heat it could trap, and whether it could melt ice below. And they found that once melting starts on Mimas, it doesn't stop. It accelerates, and really quickly. All that melting ties back to Mimas's orbit. The Moon doesn't orbit Saturn in a perfect circle. Its path gets a little stretched. That oval shape means the Moon gets pulled and squeezed by Saturn's gravity as it orbits. The same way the Moon's gravity gives us tides here on Earth, Saturn's gravity tugs on Mimas. But instead of water tides, it's flexing solid ice. And that flexing creates heat. So, at some point, something kicked Mimas into a slightly weirder orbit, maybe a collision or a gravitational nudge from another moon. The inside of Mimas heated up, melted some of its ice, and created an ocean under the surface. But then, gravity slowly started to pull Mimas's orbit back into a circle again. When it does that, the heating will stop, and eventually, the ocean will freeze all over again. So basically, Mimas is in its warm ocean-having phase right now. Computer models show that the orbital change probably happened just 10 to 15 million years ago. That's nothing in space-time. It also turned out that the heat on Mimas doesn't move in a simple straight line. It kind of loops and twists, depending on how thick the ice is, which means finding this ocean won't be easy, but it's not impossible. Studying possible ocean worlds, and the ones of which we already know for sure, like Europa, Enceladus, Titan, and Callisto, is crucially important for us down here on Earth. Every time humans find liquid water somewhere new, we're basically discovering another version of the one thing that made us possible. Earth's oceans gave birth to everything alive, including us humans. When scientists learn how Europa's or Enceladus's oceans stay liquid without sunlight, they learn something about Earth's deep sea vents, about heat and balance. When they model Titan's chemistry, they're basically looking at what Earth might have been like before life began. So maybe life isn't that rare, and one day a probe will dip into the icy ocean of Europa with NASA's Europa Clipper, or scoop up water from Enceladus's geysers and find something, even a single living cell. And when that happens, it'll rewrite everything we think we know about life. It'll also remind us we're not the center of the story, but just one chapter in a universe full of water.
In 2024, Earth was joined by a mini-moon that orbited around our planet for 2 months. It hung around, made a few laps, and then, like every polite guest, it left. It went back to resume its trip around the Sun. However, astronomers now say another rock has been tagging along with Earth not for weeks, but for 6 decades. It's rare and strange, now being classified as a quasi-moon. But what exactly does that mean? Is it like a backup satellite? Unlike our cool and mysterious moon that illuminates our nights and affects werewolves, a quasi-moon doesn't circle Earth. Instead, it orbits the Sun, but it does so almost in perfect sync with us, like a runner doing a marathon with you that keeps a similar pace. Space only seems calm. It's actually pretty chaotic. The Sun, the Moon, Earth, and even other planets are constantly tugging on each other and smaller objects like these rocks. Most asteroids can't hold this delicate balance for long. They either get nudged into a new orbit, pulled closer to Earth, or flung out into the vast reaches of space. That's why we're lucky to spot more than 1 or 2 at a time. Most just can't keep the balance. They belong to a bigger family called co-orbitals. In fact, astronomers group them into a few types based on how they move relative to Earth. But unlike the real moon, that's been our companion since the very beginning, these visitors don't stick around forever. Some hang with us for a few decades, others for centuries, before drifting away because the gravity of some other space object. Kinda like a dog running to your neighbor after smelling bacon. One other thing about quasi-moons is their size. Most are tiny, building-sized or even smaller. They're also so dim that they can hide in plain sight among stars. Still, they're important. By studying them, astronomers learn how small near-Earth objects move and how long they can stay caught in Earth's gravity. Quasi-moons are closer than other asteroids on the same path, and it would be easier to reach them. One day, they might be used as stepping stones in space exploration. Earth has had a few of these tag-alongs before. One of the most famous is 2016 HO3, nicknamed Earth's Constant Companion. It's only about 300 feet wide, but it's been keeping pace with us for nearly a century. Researchers say it might keep up for centuries more. But what about the most recently discovered one? The researchers named it 2025 PN7. Like we said, it's already been with us for 60 years and will likely stay for around 68 more. For a long time, it remained undiscovered because of its tiny size, only about 62 feet across, which is about the length of a bowling lane. This also answers the question of whether you could see it yourself if you knew where to look. Its backstory is a bit of a mystery. Astronomers haven't figured out its composition yet. Right now, all we know for sure is its trajectory. Some quasi-moons are just near-Earth asteroids that fell into a perfect orbit. Others seem like they could be chunks of the moon itself. For instance, there's another quasi-moon named Kamo'olaoa that reflects light in almost the same way as the lunar rocks we brought back during the Apollo missions. Because of that, some researchers think it might actually be leftover from a huge impact that happened long ago. There's also 2024 PT5, a temporary mini-moon from the end of last year. Tests showed that its surface looked like lunar basalt, suggesting it probably came from the moon. So how do these quasi-moons pull off their cosmic balancing act? That's because it's just an orbital illusion. Remember, PN7, like other quasi-moons, isn't actually circling our planet. To us, it looks like the rock is scribbling lazy loops around Earth's path, like doodles in space. Yet it never lags too much or gets too far. Astronomers call this a 1-to-1 resonance. In plain English, it makes a lap around the sun every time Earth does. Another fun question. If these fake moons are so close to Earth, why don't we just pull them in with our gravity? Especially since they're tiny and seem so near. That's because even though they belong to a group called near-Earth objects, quasi-moons are not that close. Our moon is hanging out about 239,000 miles away. These companions, though, are flying around the sun millions of miles out, way beyond Earth's gravitational pull. That pull exists within an area called the Hill sphere, which is where Earth's gravity is stronger than the sun's. Think of Earth's gravity as a bubble with a radius of about 1,000,000 miles. Anything inside can get caught, like the real moon. Step outside and the sun takes over. This is exactly what happened to PT5, which was our legit satellite for 2 months in 2024. It dipped inside the Hill sphere and Earth's gravity took over. Once it happened, this object became known as a mini-moon. But because it was small and moving fast, it eventually slipped back out of that bubble, and the sun's gravity pulled it away again. One other type of co-orbiter, aside from quasi-moons and mini-moons, is the so-called horseshoe orbiters. These space rocks don't stray far, but from Earth's point of view, they seem to swing ahead of us, slow down, then drift back behind, and repeat. It's like an undercover cop tailing you in traffic, but constantly switching lanes and doubling back so you don't notice the pattern. If you trace their motion from Earth, over time, it forms a giant horseshoe shape, hence the name. And these are just the main co-orbiters. There are actually more. Way ahead of us and way behind us in space, there are a few quirky rocks called Trojans. They're not just following right next to Earth like quasi-moons do. Instead, they found two special hiding spots. One 60 degrees in front of us and one 60 degrees behind. Imagine riding your bike and having a friend way ahead of you and another one way behind, both keeping the same speed. That's what Trojans do. Those spots are called Lagrange points, cozy hangout regions where the gravitational pulls from Earth and the Sun balance out perfectly. When they find themselves in one of those areas, they could be staying there for millions of years without drifting away. Jupiter, for example, has tons of these freeloaders. Earth has only a few. Then there are tadpole orbiters. Instead of sitting perfectly still in a Lagrange point, they wobble around it in lazy bean-shaped loops. And if that's not confusing and overwhelming enough, there are also jumping Trojans, the indecisive ones. These guys can't pick a side. They'll spend a few thousand years staying in the front hammock, then slowly drift to one behind us and back again. Rare, weird, and kind of awesome. So even though Earth only has one big moon in the sky, we've actually got a whole gang of intrusive space tag-alongs. Some loop, some trail, some hide in the corners. Now let's recap the superpowers of our moon. It can affect tides, slow down Earth's rotation, and even help stabilize our planet's tilt. Without the moon, our days would be shorter, our nights darker, and the seasons way more chaotic. The moon also acts like a giant shield, sweeping up or deflecting some space rocks that might otherwise smack into Earth. And let's not forget its cultural influence. It's been inspiring myths, calendars, love songs, and millions of melancholic walks in the middle of the night. Fake moons can't compete. However, they are important in their own way. Each new quasi-moon we find helps us understand how these little rocks survive in all that cosmic chaos. By learning about our environment, we also learn something about ourselves. They sharpen our detection skills and help us improve our models. So while they'll never shine in the night sky, they still play a quiet role in helping us understand our quirky cosmic neighborhood.